We're going to start with an introduction of just what is trigonometry? What is this thing that we are getting ourselves into? So trigonometry is the math that's concerned with relationships between angles and ratios of lengths. So trigonometry is about a relationship between angles Oh, see, now it's more wholesome. It's the math of relationships between angles and lengths, ratios, I could say. It's where we combine things like angles and ratios of length, angles and length. It's the bridge between those two things. So there are some things that we know about triangles already. If I draw a right triangle, what does it mean to have a right triangle? There's a 90-degree angle. See, you all have math knowledge already. So a right triangle just means that one of the angles is 90 degrees. We mark a 90-degree angle with a little box saying it's a little square in the corner saying this is where the 90-degree angle is. So that's a right triangle. It has a 90-degree angle. When we have a right triangle, I suspect that you know what one of these sides is called. One of these sides has a special name. What is that special name? Hypotenuse. Which one of these is the hypotenuse? The hypotenuse is the side opposite the right angle. So that would be this side up here is the hypotenuse. A couple of things going on in this statement. First of all, the name of the side opposite the right angle is the hypotenuse. Furthermore, we've also used the word opposite. That means if we're standing in at the right angle and looking across the triangle, we are looking at the hypotenuse. That is the side opposite the right angle. The other two sides of this triangle, the hypotenuse is always opposite the right angle. The other two sides in a right triangle will be called legs. So these are all categorized as sides of the triangle. A right triangle will have a hypotenuse and two legs. Reading your minds. Oh, wait, I'm not supposed to do that. So not reading your minds. I know that some of you know something about the relationship of the sides in a right triangle. What is that thing? What's it called? Or what is the thing? Some of you are thinking it right now. It's a Greek thing. What's that? Theta is going to be one of the things that we put in. That I threw you off by saying it's a Greek thing. There's a Greek dude that's named after it. Yes. Ooh, that's awesome. That's where I was going to go. Yeah, the sum of the angles in a triangle is equal to 180. What's something that relates all the legs? The Pythagorean theorem. Well, how do we say the Pythagorean theorem? What's the shorthand for the Pythagorean theorem? A squared plus B squared equals C squared. And which one of those three is the hypotenuse? C. C is the hypotenuse. So great. That's two things that we know about triangles. One, the Pythagorean theorem. Which we usually say A squared plus B squared equals C squared. This requires us to make sure that we all understand that the hypotenuse is going to be called C. Always the hypotenuse is C. If we're going to say A squared plus B squared equals C squared. C is the hypotenuse. The reason that we want to say it this way is that we don't want to say the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. That's a lot. It's easier to just say A squared plus B squared equals C squared. What that means is that the two legs are A and B, and the hypotenuse is C. The sum of the squares, the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. That's great. That's something that we know about the sides of a right triangle. Pretty specific, right triangle, but right triangles, very, very useful. Another thing that came up is that the sum of the angles in a triangle is 180 degrees. Has everybody heard that one before? Heard that one before. In fact, you all have, because I just said it. And that happened before I asked the question. So anybody who said no is incorrect, minus 1,000 points. Just kidding. It's minus 2,000 points. Do that enough, and you'll have to go all the way back to elementary school. It's pretty rough. I'm just kidding. That would be cruel. That's great. There's two things that we know about triangles, about right triangles. We know that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. And we know that the sum of the angles in any triangle, right or not, is 180 degrees. That's two things that we know. Let's look at those two things. One of them, all sides. The other one, all angles. We need something to connect those two. And that's what trigonometry is about. It's the relationships between angles and ratios of sides. It's a connection between the angle stuff that we know and the side stuff that we know. So we need to connect. So this is all angles. I didn't check to see if my pen was ready before. And this one is all sides. So the Pythagorean theorem is about a relationship in the sides and also specifically of a right triangle. And the sum of the angles is 180 degrees is something that's all angles. It's only angle information. We need some kind of connection between the two. We need something that connects the sides and the angles. We need something that's going to connect angles and sides in a triangle. This is where trigonometry enters the chat. Trigonometric functions are going to be something that we can use to connect the angles in a triangle to the sides of that triangle. We're going to start by introducing trigonometric functions in a right triangle. We're going to start by just using a right triangle. Let's write down what they are. So in this right triangle, we can see where the right angle is. Opposite the right angle is the hypotenuse. I'm going to give a name to one of these other angles, one of the acute angles in the triangle. I'm going to give a name to one of the acute angles in the triangle. What's an acute angle? An angle that measures less than 90 degrees. So if an angle is less than 90 degrees, it's an acute angle. What do we call it if it's more than 90 degrees? Obtuse. See, you guys have all this like secret math knowledge. Gotta figure out where all this knowledge can remember some stuff. Those of you watching this video later, I'm reloading the pink pen because it was bothering me. It shouldn't. I should be able to just let that go, but good luck with that. Yeah, that's better. So we're going to give a name to one of these angles. I'm going to say this angle down here, I'm going to give it a name theta. So to make a theta, you just make an O and like slash through it, or make a 0 and then cut through the middle of it. This is a lowercase theta. Now, the theta is not going to be the right angle. The right angle and the hypotenuse, they're already a thing. But I'm going to say this angle down here is called theta, and this is going to give me names for the other two sides relative to theta. And some of you, my theory is that some of you know this already. What is this vertical leg? Here's theta. What do we call this one? Opposite, because this is going to be opposite theta. So that side is opposite theta, because if you're standing in theta with your hands on the two sides that make theta, you're looking at the side opposite theta. That's what we mean when we say opposite with angles and sides. What do we call the other side? Sorry, what do we call the other leg? Adjacent. See, you guys know so much already. It's awesome. It's going to be done in a week. Once we pick an angle that gives us a perspective, we'll have one side opposite, an adjacent, and a hypotenuse. Opposite will be abbreviated OPP for opposite. Adjacent will be abbreviated ADJ for adjacent. We're not going to get too fancy coming up with abbreviations for things. Now we're, okay, go ahead. It's whichever one you want it to be. But if I say this angle up here is theta, then this would be opposite and this would be adjacent. So whichever one, theta kind of defines what your perspective is as far as opposite and adjacent goes. You can't just say opposite and adjacent without having a theta already, some angle already involved. So I've got the three sides are opposite, adjacent, and hypotenuse, and I've got this angle theta that we use to define opposite and adjacent. Now we're going to introduce three trig functions that relate the sides and the angle. Anybody know what they are? Sine, cosine, and tangent. So the three trig functions that we're going to start off with are sine, cosine, and tangent. These three trig functions are going to complete our relationships between the three sides and the three angles of a right triangle. It's going to be a connection between the angles, one angle in particular, but we get the other one kind of for free, and the sides. The abbreviation for sine is SIN, so we write sine. And then since we're writing, we should put theta in parentheses. We won't always do that, but we're trying to build good habits. That's what got us here today, building a habit. But the habits will carry us through motivation. Because motivation will certainly fail us soon. Maybe not today, maybe not next week, but someday you're going to get up and go, man, I'm not going. Motivation will be gone. But if you build up enough habits, you show up in class like, well, how did I get here? So sine, then parentheses, we put theta, and we say this by saying sine of theta. Does anybody know what sine of theta is? We say sine of theta is opposite over hypotenuse. It's the ratio of the opposite to the hypotenuse. Pronunciation guide is sine of theta. The parentheses aren't indicating multiplication. The parentheses are like function notation, where we say things like f of x. The next one is our abbreviation for cosine is cosine. And then we'll put the theta in parentheses. Cosine of theta is, does anybody remember? It's okay if you don't remember, or if you never knew. That's why you hired me, to like tell you this shit. So I just want to find out. Cosine of theta is adjacent over hypotenuse. And what is tangent of theta? Tangent of theta is opposite over adjacent. The important thing to remember is that this only applies to right triangles. It's obviously only applying to right triangles for sine and cosine because we use the word hypotenuse. We can't have a hypotenuse without a right angle. So we're definitely dealing with a right triangle in those two. But since we're saying things like opposite and adjacent, this right triangle thing still applies to tangent. Saying opposite and adjacent implies that that third side is a hypotenuse. So even though we're not saying hypotenuse in tangent of theta is opposite over adjacent, we are saying opposite adjacent, and the third one is hypotenuse. Any questions? So this is relationship between the angle and the sides of a right triangle, only for right triangles. Some exclusions apply. And everybody's like, I see how it is. What you have to remember, the things that you need to remember right now, like right now, you have to know this right now, whether you knew before or not. These are things that we know about right triangles. We know that the sum of the angles in any triangle is 180 degrees. That we know. In a right triangle, we know the Pythagorean theorem, a squared plus b squared equals c squared. And now in a right triangle, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. You don't have to memorize these things, you just have to remember them, starting now and remember them forever. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent in right triangles only. We're not going to say that part all the time. So there are a few ways that you can remember this. If you remember that you're going to go in sine, cosine, and tangent order all the time, you can see the OH and the AH and the OA. Just use that first letter, and you could be OH, AH, and OA, and be like, oh, heck, another hour of algebra. And just remember that you're doing sine, cosine, tangent. You could also abbreviate it SOHCAHTOA, SOHCAHTOA. So that's usually pronounced SOHCAHTOA. I don't like that one because when I learned trig, the way I was presented with SOHCAHTOA was super racist, and so I'm really against that one. So the mnemonic that I use for this, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That's the one, the mnemonic device I use. I'm not very clever with my mnemonic devices, so. But I like, oh heck, another hour of algebra. But it does require you remember sine, cosine, tangent is the order we're going to go. Any questions? Is everybody okay? Everybody good? Everybody good enough? Correct. Let's take a quick break because I've been talking enough and you all are sick of it. I can keep going, but one of you would like, there would be rebellion if I just keep going. So, all right, let's take a break, come back in 10 minutes, and then we'll do our next activity for today. Memorize this.